right. Hello. Thank you for coming. First question. Does anybody know where those voices came from? The voiceovers that just told you to turn your stuff off? OS 10 Assistive Technologies voices. So that was part of MCP that I wrote that do the say command and pipe it in and using the specified voice. So I like that one. Actually, that's one of my favorites. But hello, I'm Justin Elliott. I'm an IT manager here at Penn State. Probably you've seen enough of me. But I've been a developer for a long time, probably 20 years now. And through the years, I've used source code management tools like Subversion and Git. So last year, I did one for system administrators. And that went pretty well, but I felt there were some things we wanted to add this year. So Matt Hansen has graciously offered to help with this presentation. So Matt, can you talk about yourself a little bit?
My name is Matt Hansen. I work in the classroom and lab computing group at Penn State. And I've been using Git for probably a few years now, and I think increasingly more I use it for We collaborate a lot within our group, and I tend to do a lot of automation projects because I don't like doing the same things over and over. So that's sort of where this presentation spurred from.
So we'll go ahead and jump in and get started. So today, the agenda is going to be, we're going to talk about the basics of version control because that's pretty important. You're probably, some of you, I recognize some faces. You may think, yeah, I know Git already. So the first part is the basics, and then we'll get into the really fun stuff that Matt's going to talk about. I'm going to talk about the boring stuff. He'll talk about the fun stuff. And then but there are some foundational things that you need to understand about Git just to get started. Git can be incredibly complicated, and it's really got a lot of power, but GitHub and other services have made it pretty simple to get started. So we want to definitely touch on those points. And there's some advanced Git features that you'll need to know in order to collaborate at your best and work with others. And then Matt will dive further into the collaboration, what he's done in that space, and automating Git into your various workflows. So that's the goal we're trying to accomplish today. Okay, so first we'll jump into version control. So what exactly is version control? Well, you can probably tell by the word, you're controlling or managing versions of files. So that could be pretty important when you have a shell script or Python or anything that you're working on where, let's say you have a script that's working and I've done this, we've all done this, you're working on something, it works, you save it, you run, it's like, great, oh, I should save that. Oh, I'll put it in a folder here and save that. Folder, right? I see a few people smiling because they've done it. Okay, I've done it too. Version control helps you to prevent doing that, encapsulate your changes, and it's a lot easier to manage your source code that way. So what I wanted to mention, there are multiple ways or terms that you may have heard over the years. Source code management or version control systems, they're pretty much the same thing. And GitHub, which I'm sure most people in the room have heard about it, but if not, it's a very popular web hosting service for hosting Git repos for free for public use. There are others that we'll mention as well. So it's a system to basically help you manage versions of your files and projects. Okay, so why would I want to use it? Well, we touched on this a little bit, but it greatly reduces the risks of messing things up, that something's working, you can capture those changes and save them. It also is a way, and in turn enables you to experiment freely. So I do this all the time with MCP. If I'm trying something new and it doesn't work, I can just say, well, that didn't work. Okay, throw that away and try something a little bit different. Or if I'm typing at night on the keyboard and I fall asleep, then you know that's a mistake. Git also is fantastic at showing you the differences that you made. So that is yet another way you can say, what did I change? So that's another reason that it helps to protect and keep your sanity and let you experiment. It has fantastic agility. Git is extremely well documented. It ties in with many different services. Matt will cover a lot of these, but gives you the ability to tie into your workflows. Let's say you're working on updating a website on your local machine, you're testing it here, and you want to push it to a repository, a hosting service. Your server or servers or whatever could listen and grab what is called a hook and get those updates right away, rather than having to secure copy or file copy. And so let the computers do the boring stuff. Let us do the fun stuff, right? It touches back on what Matt said about automating the boring stuff and moving and developing and innovating. So quicker deployments, automatic updates, so that all of that can tie in with Git and have server pull that information. It also is self-documenting in a way. If you write, it's on you, of course, to write good commit messages when you save changes to your repository. We'll talk what that means to a repository in more term definitions, but it is a way that when you save a commit, you have a one-line sentence or more information. Others can read that, and that, in a way, is documenting as well. So you can use it for release notes, or this is for El Capitan, or Sierra. So there are ways that others then can view those and see what you did. And then also you help yourself down the road and you say, why did I do this? What was I thinking? Oh, this is why, okay. And then collaborating with others, of course. It's probably by going to their sessions here at MacAdmins, you've seen how much it's being used, and others are collaborating with scripts and doing what are called pull requests, contributing to code. So that's been very huge for the community as well. Makes it so easy. GitHub, Bitbucket, all of the great hosting services out there. And modifying a project for your own use. You can do what is called forking, which takes it and forks it, makes a copy, and you can use it for your own, and you can modify it and say, hey, I have this new feature, I want to push it, or create a pull request to the original author, and they can implement that, or not. So it's great for social coding. So a quick introduction to Git specifically, which is a source code management tool, of course. Currently, it's probably assumed, and this may offend some people who like Bazaar or Subversion or Mercurial, which are also good choices. But why Git? Well, right now, at least this month, Git is the current de facto standard for source code management. I think it's been pretty well established and understood that it seems to be the winner right now. And like anything, they always learn from the previous technologies and build on that, right? Like Swift 3 and languages. It is easy to learn. It is complicated. It can be complicated, but it is easy to learn if you stick to the basics. Most people will feel overwhelmed. If you go and read the documentation, when I first started reading, I read the whole Git Pro documentation book. Holy cow. But it was good, but it's a lot to learn at first. You don't need to learn all of that. There are the basics, and GitHub and other sites make it very easy to start, which is nice. And it is very powerful and extensive, as we've kind of alluded to already with the various workflows and things you can add to it. So Git is, another advantage of it is extremely fast. And what I mean by that is, let's say that you want to commit a bunch of files to the repository, and you say commit, boom, it's usually instantaneous. So of course with SSDs today on machines, it's very fast, but it does a SHA-1 hash of everything in the particular repository. The repository, for all intents and purposes, is a folder and a directory of files. And it's amazing how fast it can detect any change in that directory structure. You think sometimes you committed a bunch of new files, like it could be gigs worth, it's so quick you're thinking there's no way it could have done it that fast, but it's very fast. The other advantage of Git is that it is a distributed model. So those who have used Subversion, I did years ago. I've been using Git for probably about 4 years now. Let's say you're traveling, going on an airplane to get to State College, and you're using Subversion. You had to wait to push your commits until you landed and got to network, unless you have go in flight. But with Git, you can save changes locally to the repository, and then move on, and it doesn't hold up your development cycle. And then when you get to the network, then eventually you push all of those changes at one time to the hosting service if you want. So it allows for flexibility. Everybody that has subscribed to the repo has a full backup copy, which is nice. So you can do a shallow clone if you want, what is called a shallow clone. That would allow you just to check out a small portion, but most people check out the entire repository, which is nice because you can go back in history and see what versions you want to get in case there was something older that worked and you want to go back to that. But again, you don't need the network and you can work locally when you get to the network, and that's when you push. So it's extremely flexible with that. So I've thrown around the word repository, and basically a repository is a folder or directory that Git has created a .git folder in the root of. That .git folder contains everything that Git requires to manage your repository. Don't touch files in that directory, but you can look, of course. And there are files like under refs and config and all of those, and many various directories. Git has I'm summarizing because we really don't need to talk much about it because Git manages all of that. But it's basically this way of keeping track of what you have in your repository. What's also nice is it makes that folder directory completely mobile. So if you take that and you want to move it to a completely different location, that repository, that it's self-contained, you can move it very easily. You don't have to look all over your file system for different files. So it's very well self-contained. Okay, so local would be on my machine. Remote is the actual server itself where you would be pushing files to and updating the repository on the server side. The working directory is the current working directory where your files are stored, where you have a shell script. And then lastly, you do what are called commits. That means you're taking changes to a file and you're committing, saving to the repository an entry with text that says what you did, and it shows you the files, and also then Git will know the differences of how those files changed. All right, so those are the basic terminology. And if we mentioned, or if you have any quick questions, let us know, and then we'll have some time for Q&A as well. So let's jump into how do you install it and configure it. Well, what's nice is that it's embedded with many Git GUI applications. It's included with Xcode. Apple has their own version as well. And also it's included with GitHub and SourceTree. I tend to use SourceTree. GitHub is also really nice because it simplifies a lot of the complex tasks. And then, of course, you can use the terminal quite a bit as well. Whenever I do a Git presentation, I've leaned it one way to doing completely GUI or the other way towards terminal. And I always upset half of the crowd, right? Because I can't make everybody. So there's a good balance here. Where I'm going is it's good to learn the GUI tools. SourceTree makes a lot of advanced features more readily available to everybody. And I know everybody's really smart in the room. But it's still good to know the terminal because occasionally SourceTree and other GUI apps don't give you the right error message on what the problem is. And then it's good to know the terminal still to figure that out. But most of the time I live in SourceTree and it's been working pretty well. So use whatever you like. And what's nice is if, let's say you create a repository with SourceTree or GitHub and you don't like that particular app and you want to move to Tower or something else, you can do that. The repository is not application specific. It is a Git repository. So you don't have to stick with that particular application. And then Mac OS now. You can install Mac ports and Homebrew and install it that way. What's nice about those options are there was a Git exploit that was either 2.2.1 or 2.2.4. And Apple and others embedded, it took a while for them to update their version of Git. Well, through Mac ports or Homebrew, you could immediately update on the spot right away and get the immediate patches, which was nice. So, and there was a lot of good documentation out there as well, how to do that. So I talked, yeah, sorry, this is a repeat. These are the URLs. I know everybody knows how to Google, so we'll go ahead and move on to the next. So reviewing diffs, that would show you the differences between a file as it was committed and what you changed to it. There are very nice views for this within the GitHub Desktop application as well as the web interface, which is very nice. And of course, you can use file merge, which comes with Xcode, and Kaleidoscope. Yes, it's pretty expensive, but it's very awesome and cool. So I bought it when it was cheaper, but it's fantastic for doing diffs, viewing, and also for merges as well. Really quick, I'll also mention this. The slides will be available on our MacAdmins website within the next week or two, so feel free to type, of course. But we will have the slides available, and the URLs, of course, will be exactly as they are in the document right now. So you could also, sorry, let me back up. Git also has a function where you could say git diff, and it would show you the differences of the files that have been committed to. So if you're happy in the command line, that's great. You can use that feature as well. So as I mentioned, the GitHub Desktop simplifies the complex, easy to start with. And when you get there, it's limited in feature set, so, which is by design, which makes it easier to use. If you get there and you think, oh, this is great, I'm happy there, stick with it, use it. But if you're wishing you had some more features in it, try SourceTree or Tower or one of the other tools. And again, the repositories are portable, so you can jump if you want to go to a different application. So we're going to focus on GitHub today because that's been the most requested one to cover. So we'll go ahead and jump into how to config the client. So this is the newest fresh update. These are newest screenshots, and they changed their app from GitHub something to GitHub Desktop. So you launch it. It'll ask you to log in. You'll need to go to the website to create an account. It might let you create an account here. Nope. Definitely create the account. Now this stage is important because it makes everything simple for when you create repositories and interfacing with the GitHub web service. So you'd log in, and I've got 2FA enabled on my account. Strongly recommended. So if your password ever gets hacked or something on any of the services, they can't do much without the two-factor authentication pushing to their own phone. So strongly recommended. I know it's an extra hassle, but 2FA has made it easier with my watch and other apps that help that process. So anyway, so you may not see the 2FA stage. So once I've logged in, then you can click continue. And also in this point, I selected the install Git command line tools. That is nice integration with GitHub. I tend to stick, if I'm going to use the GUI app, I stick there. At the terminal, I use the native Git application, or the native Git command line tool arguments. Okay. So now this is asking to find local repositories on the machine, not on the GitHub service. I didn't have any created at this point, so you're not going to see any. What it does is it scans your home directory and says, oh, do you have any that you'd like to add automatically? Merely just a convenience, which is kind of nice. Or if you want to configure it on the command line interface, you would install it based on the previous URLs, type in git config, and then enter in some information that's critical to your user account. I think we have that as the next, yes. This is also, you want to do the config process because it's critical for configuration, or sorry, collaboration. It's your name and your email address so that people, when you make commits, they know who you are and what name to link to. So, if it works. All right, so here we go. This is what it looks like at the command line, so we can show you the cute animated. So you would type in git config. I'm typing. User.name and user.email. And then to show the config, it would show, okay, I know this information. So and it keeps going and going and going. That's a global setting. So you can have repository-specific settings, which I actually have, and then sometimes you can have global settings. So what that means, the reason global specified is that if the repository you've created doesn't have special settings, it'll just use the defaults for that new repository that you created. So for example, at Penn State where I work, I've got some repositories that are for work only, and I've got some on GitHub for the open source things that I do. I want my Gmail account there, but I want my Penn State ID for the internal repositories at work, so I use those separate settings. It's easy to configure through the GitHub and source tree. All right, so fundamentals of Git. How about I take a quick break, really quick questions. I tend to talk fast. I try not to. If there are any quick questions, I'll address those. Okay. Okay, if not, definitely we'll get to the end, and feel free to please ask your questions at the end then too. Okay, fundamentals, okay. So there are three main file classifications within Git. Something that's tracked, that means you've told Git, watch this file and tell me any changes on it. Ignored, ignore it, pretty straightforward. And untracked. So untracked is nice because it will show you, hey, there's a whole bunch of new files. I don't know what you want me to do with them. I'm not going to touch them, but do you want me to track them or ignore them is usually a good thing to notice. Now, some files can stay untracked if it's a file that you want to know is there, but you never want to go in the repository. Or some are ignored, like .ds store files and other files that you just don't want to push to the repository, and we'll cover other file types. So once Git is tracking a file, this means that it's watching it. It wants to know what's going on with that file. It can be either modified. You've committed it the first time, and that makes it tracked initially. Thereafter, it says, okay, you've modified this file that you want me to track, and it'll show you on the diffs. Or it can be called staged. Staged is if you read the Git documentation, they talk about taking, let's say you have 10 files, and you change 2, and you change 2, and 2 of them, let's say, relate to a particular bug or problem. You can commit just those 2 into a staging area, and Git will say, okay, I know these have changed, but you only, for the next commit, want to add these to the repository. So that's staging them for the commit. GitHub doesn't show this directly, the desktop application, but it shows it as checkboxes. Source tree has another viewing mode where you can say, drag it into the staged area, and it really, for me at least, it helps to organize my thoughts of what's changed and what I want to have committed on the next stage. Because I've been bad. I've been coding for like 4 hours or something, and I didn't commit anything, and I made a bunch of changes. I shouldn't do that. I try not to, because then it makes it harder to pick things apart. So it's better to get in the practice of change a few things, encapsulate a fix, and then commit it. And then a file has been committed in the repository, and it says, I know this file's here, hasn't changed, but it's fully safely stored in the repository. Okay, so we're going to show the concepts, and then we'll actually show the how to do this. So You're going to say, well, I want to see a command line and video. Well, that's definitely part of this presentation. All right, so the concept is you create a new empty project repository in the working directory. And then you would, so that's create a new folder or directory. Use git init to initialize it. Say I want you to this folder to be a repository. I'm going to add some files for you to track to the staging area. Then I'm going to commit those that are in the staging area, and it saves it securely in the repository. Then you can keep coding and modify those files. So I've mentioned a commit quite a few times. The summary there is basically, it should encapsulate a single fix. I touched on this. Try to keep them small if you can. You know, I'm not saying the commit, dog, the, you know, it's more of like encapsulate a single idea. So for example, I needed to change a color or something on MCP, and the way the categories get drawn at the bottom. So I'll make a quick fix, dynamically size the boxes, and then commit that. And then now I have to work on something else. So it's good to encapsulate changes at one time into the repository. So it helps you to separate each particular problem or bug that you want to fix. And then, as I touched on, larger changes are much harder to pick apart. Becomes tedious. So there are, as I touched on, there's some so there are files now you want to ignore. So Git is very good about not wiping out changes you've made to a file. So let's say that you've created a bunch of files, and if they're ignored, Git will never touch them. It will not show them as new, and it will never touch them. So files you'd like to ignore are, like we mentioned, .dsstore, really big files, your database files, a secret file that has an encrypted password, and something you'd never want to go in the repository. Things like that are when we recommend you add those to a particular git ignore at the very beginning. And you're thinking, well, I can't know possibly all the files that I'm going to need at the beginning. Well, that's okay. You start out with the git ignore, and you add them as needed. And then when Git sees a new file, it'll show you, I don't know what this is. Do you want me to add it? And you're like, whoa, I need to add that and ignore that one and put in the ignore file. So it's great at showing you what has changed within the directory, and you can ignore it or delete it or track it. Then you can also use Git to review the history logs. This will show you all of the different commits you've made over time. They'll have a long hash and a whole bunch, and then they'll show you the file differences. But it's very helpful for documentation and your future self for the reasons we've mentioned previously. So the demo is going to include, we're going to create a repo, a repository, create some files, show how they've changed, ignore some files, and that'll create a new git ignore and do the initial commit of the file. Modify that same, and I'll go through the bullets. Now I have a video as a backup in case the demo gods are not nice. So we'll try it here live. I've got Ethernet, so I should be okay. Oh, sorry, I'm ahead of myself. Yeah, this was actually the video, sorry. I was talking about remotes, my apologies. So I'm actually typing, yes, I'm typing. I'm just very good at not looking. So we make the directory here, and okay, oh, sorry. I missed the pause button. Was it gonna let me do that? There we go, okay. All right, so here we are making migrate project directory, and we're changing the working directory to the directory, and we said git init, nothing else. It says, okay, I've just created a git directory within that folder. That's where Git's gonna keep all of its stuff to track the repository. Be very careful to click here. And then, survey says, it's catching up. This is the one where it's 5 seconds. Yeah. Okay, so now we're gonna list the directory, and you can see there's a .dsstore file, and there's the Git directory. Well, we don't. And so if we show what's in the Git directory, as we mentioned, there's other information there. Don't touch that stuff. You can look at it, of course, but recommended not to change that because that's what Git is managing. So let's create old school Vim, yeah, right. We're going to create a readme.md file, save some text, exit out, it saves that file. There's the file contents, so we'll cat that. And then we will say, Git, show me what's going on here. So now Git is showing, I know this won't be on the recording, I apologize. I'm pointing to .dsstore and readme. The pink letters. Right now Git says, hey, I see 2 new files in this directory. What do you want me to do with them? They're untracked. So they're not ignored, and they're not tracked yet. So it says, hey, just letting you know. So now next, we would, just looking at the timer, is that cheat? Okay. So now we're going to say echo, and we've just added .dstore to the git ignore. So now in that file, of course, we'll say, now, notice what's changed. No longer says .dstore, it now lists .gitignore in place of that because it's now ignoring .dstore, but .gitignore is now new. So you do want to track that. Git knows that that is the ignore file for itself to look at for that particular repository. And then there's also the README file as well. So we'll continue on. Now we're going to add the gitignore. And then we'll see the status. Now it's showing up as a new file. So now it says, OK, the next time you do a commit, what's staged right now in green will be added to the repository and saved. OK, now we're going to do the commit -m for the message. Add our message, what we want it to appear. And it will now show us that it's been saved to the master branch. And one file has changed, and it also changed the mode on the gitignore file within the Git file system. It has its own file system in its directory. But basically, you care, did it add it? Yes. That's basically what that's saying at that point. And so now we'll show the status. Now we no longer see the gitignore.dstore file, which is nice, but we still see the readme.md file. So we want to take care of that one. And then we would use git again to add that to the staging area. So when git says, OK, you're going to track that one. Great. What do you want to do when you commit? It'll take all of those files that have been added. And now the commit message is added readme. And there you go. I think next one status. So now we've added 2 files. And it says it added it. And now we're going to change that file. Save that. And now we're going to say, now the file's been tracked by Git. And now we're going to say, hey, it says, hey, I know that that's been tracked. And now you say, oh, OK, what did I change? So you can see under Git diff, right underneath where it says modify at the top, it'll show you this is what you changed in that file that I'm tracking for you. So it's really nice and it stands out. It'll say immediately, this file was changed. And I can't tell you how awesome it is to know, oh, yeah, 2 hours ago I changed this file. Whoops, I completely forgot about that. So it's really nice to show everything has changed and what has changed in the file itself. Very, very quick. So the green is what's new. The purple, some file contents, was obviously the old minus plus change. So now we're going to, again, stage the file, make the commit to save it to the repository, and then we'll show the log. The log, of course, now shows the commit history. So at the bottom is the oldest. And Joe Demo, AKA Matt, is showing you how we first created a gitignore, and then added the README, and then updated the README file as well. So that shows you the dates. You can use git log to also show you some small, shorter versions of the diffs if you want to. And the GUIs make that very easy as well to see what actually changed. All right. So we're going to cat the README file. There's the file. And then now we're going to revert a change. Let's say that we made a file and we want to reset back to a previous commit. So what we're doing here is we're showing the file contents as it is right now. But let's say we want to revert that file for some reason. Well, there's a git reset hard command. And that will basically say, whoop, I want to go back to a previous commit. Now, there's a very long hash. And the GUIs make this easier to do. But I'm showing this also for the command line junkies like me to go back and forth. This is a very long number. If you use GUI apps, you don't need to worry about that number at all. They'll abstract that for you. But that number, obviously, 171 is the second commit from the top. It'll change the files back to the time as the state they were at that particular time. So we're going to cat the. Oh, sorry, guys. It's a collective, guys. All right, come on. And where were we? There we go. Okay. Hey. All right. So now it says it reverted the file back to the way it was before that particular commit. So it's reset the state of the local files back to the way it was at the repo at that time. And I think, is that it for that demo? Is there something else?
Git log at the end.
Oh, okay. Oh, that's right. We had a git log on there to show the difference of what was done and to show the revert. Okay. And we're going to show git log once again. So that's it for that. Okay. I know that was a lot. We'll take a break for really quick questions. Any quick questions? Yes, sir.
So once you get do the essentially reversion, the git hard reversion, once you do that, you couldn't go back forward again, right?
You actually, so the question was, just for the recording, once you revert back, can you go back to the way it was previously? You can. What's nice about Git, for better or for worse, it records everything that you did as a commit. So there are times when I've done a revert and I said, I want to unchange this. What's nice about Git history is that it's stored in the repository and it stays there forever. There are tricky ways to delete commits and things like that if you want. But you could go back to it and then check out that commit as well if you wanted to. So yes, you could go back to it. And there are other ways of using branches to do things more safely. So let's say you want to change this, and we'll talk about that, another line of code. But yeah, good question. Sorry, anyone else with any other questions? I know I didn't have too much caffeine, just a little bit. 3 cookies too, so that was good. Got the sprinkly ones for my son. He likes those, so I got those in my bag. Sure, yes.
Ignore files. Is that like a wildcard that will actually ignore that same file name throughout different subdirectories, or is it only that file in that directory?
So that's a great question for the recording. I'll ask it as well. Can git ignore handle wildcards for our file names and in subdirectories within that repository? And the answer is yes, it can. You can do a star dot app or anything. So .dstore will be ignored in all subdirectories in that case. You can also tell git ignore, you can specify the format to just ignore dstore files under this particular directory. And what's even cooler is you can have a .git ignore in each folder that you want. So you could say, yeah, so it's really flexible. I mean, the git ignore, it's nice, it's easy to edit, it's super easy. Subversion, when I came from Subversion to this, I was like, oh, thank God. So much easier, so it's very flexible.
I think a very common example of that would be if you're working on a Python project. Every time you execute the Python script, it's creating that PYC file. So what you would do is use the asterisk and .pyc and add that to your git ignore. It would ignore all those files. So.
Cool. Okay, so we've talked a lot today about the basics of Git. Now, branches are something that usually blows people's minds. On GitHub, if you stay on what is called the master branch, you may not use branches often. You don't need to, but it's good to be aware of them because they are very useful for providing a separate path of code development. And a great example is, let's say that I'm working on some scripts. I think Rich Troughton does this on his. He could say, for example, you could say, I've got these shell scripts, login hooks, whatever, launchd items that are for 10, 11, El Capitan, right? And that's on the master branch. Well, let's say we've got betas of Sierra and we want to start, Sierra, is that what it's called, right? 10, 12, Sierra, okay. I'm waiting for Meerkat. I think that'd be great. But Sierra, so let's say that you want to take those and you don't want to, for everybody running 10, 11 proper, you could keep those files on the master branch. Now you want to create another set of scripts that are for Sierra, but you don't want to change the original ones for master. You could make a new branch called Sierra testing, and you could say, hey, you know, Josh, can you check out this branch and then test these on Sierra? And everybody else is unaffected, but they can still see and develop or test the other branch scripts as they've changed. So it's a nice way of breaking up development for different operating systems for different years. So it's a very nice way of managing different versions of the same scripts for different environments potentially. Yeah, make sure. So like I just said, yep, others to help to test. Master is the default branch. Most people consider that there are multiple Git workflows with branching. Master is considered the one that is production. So if somebody checked out your repository, they would assume that master is the one that's good, has been tested, and is good to go. Typically in development cycles, that's how they look at it. And then you would have other branches or for testing or otherwise, or you have hot fixes where there's more testing going on. And they're great for vetting, like I mentioned, major changes. I'm making changes for Sierra, see how this goes. Okay, great. Once these are good, move them into another branch. And there are tons of workflows out there now. There was one that was pretty cool called Git Flow. I was using it initially, and I still am kind of. Source Tree and others implemented support for it, but it's pretty big. And it has lots of levels for hotfixes, release, development, feature, all of this. It gets to be a lot of branches to manage. Some people use only 3 branches. I tend to use 3. So don't beat yourselves up. If you're not following the Git flow, use what works for you. That's what it comes down to. And there's a lot of them. So a typical branch workflow, let's say first commit M1 could be for 10, 11 scripts, right? And then we say, oh, okay, hey, we've got an issue with something. Let's go test this, and it's 10, 11, 6. Let's test this, and Matt and I are working on this. We're going to branch from the main line, not affect anybody who's checking out the repository, and they're getting M1 changes. We're working, we make some changes. Does that work? No. Does that work? No. Okay, oh, I think that's it. Can you test? Yep, okay, that's great. All right, we're good. Let's push it back to the master. And now we've not affected anybody who's following the master M1 to M2 branch. So we've had a chance to move to a different branch where anybody subscribed to that repository could go to it and say, oh, there's development here. I want to see and test this. And they could then test it that way safely, and we don't affect the main line of code. So it's very, as you can see, flexible and easy way to work. I want to make a very quick reference to Git's head reference. It is a reference pointer to a commit. Why would I mention this? Why do you care? Because you'll see this. You'll run into this, and you'll say, oh, detached head. That sounds really bad. I don't know about you, but I don't want to lose my head. Matt and I always thought, like, we should have a guillotine come down on the slide or something and slice it in half. But basically, it's Git's pointer to keep track of the current state of your repository. So it's a head pointer that usually points to the top latest commit of a branch. When would it change to a detached head? Well, when your current state is now reverted to a previous commit in that particular branch. So it's detached from the head of that branch. If you find that you need to, and you're like, oh, shoot, you need to revert back to a particular change, and now you want to make changes from an earlier commit, because the later ones were somehow not good, you could then take it, branch from that point, make your changes, and then merge them back to the branch itself. So it's a safer way of working and updating the branches safely. One other recommendation with Git, I didn't mention probably in the slides, but is try to avoid, if you can, having branches out for long lengths of time. I've run into this issue where I'm working on something for MacAdmins 2017. It's going to run on, well, yeah, that's a secret. But if you have a branch that's out for a long time, you can see what's going to happen. You're going to update your master branch, and you're going to have a heck of a time merging changes into that older branch. So it's usually good with keeping branches short-lived and merge them back, unless it's a major rewrite, then that, of course, changes things. But branch workflows, I'm not going to talk about all these. That's another session entirely. But here are a bunch of them. GitHub Flow is a nice one. Atlassian does a fantastic job of outlining their documentation for Git. It's really, really good, so I highly recommend that. You'll see a bunch of them here. Check those out. They'll be in the slides. Remotes. We'll take a break here really quick. Any questions? I know this is a lot of information. I apologize. I'm trying to make it fun. Any questions at this point? No? Yes?
One slide back.
Sure. Yes? Yep. So yeah, GitHub Flow, these are just various ones they've named. Git Flow is Atlassian supports as well. Atlassian is the company that makes, well, they bought SourceTree, and they now are the developers for SourceTree. SourceTree integrates very nicely with Bitbucket. They're their hosting service, which is pretty cool. Is that good? Okay. All right, so remotes. We've talked a lot about this. What does that mean? It's a remote host that you push your repository to. So local on your local machine, and remote is where you would push your files like GitHub or Bitbucket. This one threw me for a loop at first when I started using remotes. The remote, for whatever reason, is called Origin. I don't know why. I didn't design Git. I changed the name, and I said, oh, that doesn't make sense. I want to call that GitHub or Bitbucket or whatever. SourceTree at the time choked. It says, I don't know where Origin is. I'm like, that is the origin that you should be, okay, fine. So it's just the way it was designed, but just understand that the first remote you add is called Origin. The first, what I mean by there is you can add multiple remotes if you wanted to, but that's a lot to handle tracking, and they can get out of sync. So recommend it just to start with one remote until you get comfortable. You may never need a second remote. Paranoid people like me do, but most people don't need to. Remotes you can access through HTTPS, SSH keys. The documentation's been pretty extensive for those. And the Git protocol, which is not used very often. Most of the time people just stick with HTTPS, and SSH has been working great. You can also do a self-hosted one over SSH. I do this on my home server. It's not an X server, that'd be too loud. And they're kind of, gone. Oh. So you can enable SSH, use Git, and this is well documented on the internet as well. So, but the important part is to create it as a bear shared for multiple folks accessing this as well. It's different than the standard init, which is just for local. So that makes it ready for the server side. And then you can also have on-prem with Atlassian Stash, GitHub, and GitLab. We talked about GitHub, Bitbucket. GitLab is nice. We use that here at Penn State for at git.psu.edu, which has been a fantastic service. That's worked very well for us, and many, many more. In fact, when I updated this slide, Matt and I both, I said, do some of these exist anymore? No, they're out. No, that's too bad. Oh, there's some new ones. So, but GitHub and Bitbucket seem to be really good ones. So, all right. So the remotes, I'm going to move a little faster so we can make sure we get to Matt's stuff. Sorry, we need to see the timer. Okay. So you have a working directory you add to the staging area and the commit to the repository. We talked about that in the first. That's local also so far. And now we would do what is called a push. That pushes to the remote. Then you would also do what is called a pull. So you would do a pull when somebody else updated the repo. Or you're working on something at work and you did a push. Now you want to go home and work on it. Although there's a good work-life balance, I hope. I'm trying to work on that. Then you would do a pull to get those updates and then work. Make sure you always do a pull before you start working because otherwise you get out of sync and you'll have a hard time merging files back. So that's the one using remotes. Cloning is something you'll do quite often with GitHub. Cloning is meaning copy it down and create a new repo. That repo will then include the entire project, the history of it, as well as the remote reference for that particular service. In that case, GitHub. Pushing would save commits to the server as well, and it's on the active branch that you're on. This was a behavior change they had from Git 1 to Git version 2. 2, they basically only push the branch that you're currently on because 1 would push all branches and you could make changes to it that you would not know about potentially. Fetching, this doesn't change the files on your local system. It says, hey, remotes, what are the statuses of each before I do anything local? So this is a safe way to not change your files, but says, what is the status of GitHub? Oh, nobody's made changes, or somebody did. I should get those changes. And so always recommended to fetch or pull before pushing to remotes, so you're always up to date. Remotes, do's and don'ts. Like I mentioned, yep, always fetch or pull before making any changes. Or if you do, you can create a new branch first locally or stash the files first. Stash is it's only on your local machine. It's a feature of Git where you can save a set of files that you've changed to a local stash. It does not commit them to the repository, but it saves them locally that you could then restore and put into the repository should you want to. So nobody else sees them. It's on your machine only, and it's a temporary kind of save. Remotes demo. All right, I'm just going to probably go through the video for this one probably because of time. All right, so, sorry, let me back up. We're going to add a local repo that we've already been created on the desktop through GitHub Desktop. We're going to publish it and show the status of what the remotes look like before and after, and then show the local branch, and then commit, and then push to GitHub, and then create the README. But we might need to move a little so you can get to your stuff too. All right, so is that going to play? There we go. All right. So within GitHub Desktop, you're going to add a local repository. This is going to add a local folder that's already been created. A local Git repository. Close all the welcome messages. Under the other, it shows. Just make sure I can move a little faster. Right now, it's not on GitHub. It's just in the local machine. And there are some files. And so I'm showing the 2 commits that I've done, which were very recent. In case we had networking problems, but it's been working great. We'll go to the terminal, show the current directory. There we are. And we'll say git remote, to show that there's no remote configured and there are no branches tracking on the remote side. And then we will now push to GitHub. And I'll say, add a description here. And this is after I've already configured GitHub and entered my credentials. It'll push that. And now notice how it's moved on the left side to the GitHub section. So it was under other local, and now it's on GitHub. So now it's there. And then we'll jump to the browser, we'll show the status now. Now it shows that there is a remote for that repository, and there's now a branch that's master, and it's tracking on the origin server, also on the master branch. We'll go to GitHub. I'll refresh the web page there. And now we see that there's a new repository. And we have 2 files. But it doesn't have a README file yet. So we're like, well, we'll show the commits. Yep. Virtual Justin. And now we'll add a README file. So now this is going to create a file on the server side, and this will demonstrate how we can then pull it down back to the client. We'll say thank you for coming. Commit that directly to the master branch. Commit new file. Head on over to it shows that the README file is part of the repo. And now we'll do a sync, and that'll do a pull. You can do it either way. And now it grabs that new file, and now the local repository has that new README file in the files. And we can open that in terminal, list the directory contents, and we see that there's the readme.md file. And we can show the log from all the changes that were made there. So that's it. That's it. OK. Wow, that was a lot. Sorry, Matt. I'm going to pass it to Matt, who's going to talk about collaboration.
So we've been talking about a lot of different features of Git and how powerful it is. And it's perfectly usable to use Git just on your local workstation. But when we start talking about remotes, pushing to GitHub, a lot of the power then also comes from collaborating with other people. So if you already use projects like AutoPackage or Monkey, these projects have many different contributors all working across the globe, contributing code and new features that help everyone who uses it. So I think one of the most important aspects of collaboration, especially when you're working on big projects with tons of people, is discussing etiquette. And one important aspect of that is pull requests versus feature requests. So not everyone is a born coder, and maybe if that's not your thing, you might want to create an issue under a project and say, this is simply describe the challenges in your environment and what features would really benefit you, and here's why you think it could fit into this project. And if you are a coder, try to submit a pull request. So that means you are actually forking the code, updating it to work with your environment, and then hopefully contributing that back via a pull request so it goes back into the master project. So it continually receives all the core updates, and other people can leverage the work that you've done. Because if it's a feature that you need, there's a good chance other people could use it too. Mm-hmm. Also a good bullet point here is to read before you start contributing or filing issues for a project, please read the project's documentation and the guidelines. They may have certain style guides for how the code should behave, or certain goals that they're working towards, or certain fundamental concepts that they're really trying to build their project around. And if you're not a born coder, or you're new to Git in general or GitHub, start with a very simple change just to learn the process. You can even just not submit any code, but submit new documentation. So if you find a typo or an area in the documentation of a project that's lacking, or even a project that doesn't have any documentation, you can write that and create a pull request just to pull in that documentation. And if you are the owner of a project and you are lucky enough to receive a pull request, try to work with that contributor to, if their pull request isn't perfect right away, try to work with them and explain, use it as a teaching moment to explain how they can better fit their code into your project, and let them create new, update their pull request to incorporate that. Avoid the tendency to create a pull request against their pull request, just to kind of throw up your hands and do it yourself kind of attitude. Because we're all trying to collaborate together. So you try to use it as a teaching moment and avoid doing that. So commit messages are a very important part of Git, and I think as others have described during the conference, they're almost self-documenting. So they should really describe exactly what you've changed. So keep them small, keep them clear and descriptive, and then remember that you aren't the only ones that have to use them. Other people have to look back at your commit messages and try to understand what you did, whether or not they can understand your code or not. So just be very, very concise there. And also stick to the project's coding styles. So tabs for spaces, blank lines, other coding standards. Try to follow those and make sure that you understand the language and the coding practices that the project has adopted before submitting your pull requests. Do you have something on that one?
Sorry, which one?
The follow established team.
Follower established team. That's just we're talking about the follower established team decided branch workflow. Basically, if they're don't make testing changes on the master branch, or pull requests. If they're testing something in the development, make the changes there. Work with the author who owns that repository.
Yeah.
That's
so
it.
hopefully those changes are documented, and if they're not, try to contact the project owners and find out maybe how you can best contribute before you just start coding away. And I think most important of all is just be nice. And we all have limited time. All our coding abilities are different. All our skill levels are different. So be nice. So when someone submits a pull request that isn't perfect, try to work with them on that. If they file an issue that isn't quite clear, just be nice and try to follow up with them on that. If you file an issue and it isn't fixed right away, just be patient. Everyone has busy lives and different priorities and things we're working on. So just be nice on GitHub. So I'm going to go through a quick kind of overview of what creating a pull request would look like. So the first part is you would browse on GitHub. You would find a project that you're interested in, and we're calling this the remote repo. And the first step you would take is you would look for the fork button on a place like GitHub, and doing so would then clone that repository into your own account, and you would have full control there. It's a complete copy. This new copy is completely under your control, and the original owner can see how many times they've been forked by who. And then the next thing you want to do is clone that new project from your account down to a local repository, so you can start making changes. Once you start making changes, you're in that working copy. You add those to the staging area, and you create a commit against your local repository, and then you push that back up to GitHub. So now at this point, you are one step ahead. Of your project is one step ahead of the original fork project. And then what you do is you go into your remote repo, that commit, and you create a pull request, and you create that across projects and against the original project. And that usually leads to some kind of discussion. So you're talking back and forth about why these features are useful, maybe fixing any typos or any other kind of mistakes you might have made or bugs you might have created in order to get it to work right. So you may go through this process a couple times to get your pull request accepted. But once that happens, then the original project maintainer merges that into their remote. And then at that point, you should really congratulate yourself because you've made you are now a contributor to that project.
Yay! Yay!
And if on GitHub, if you are the owner of any projects, you should feel really lucky that you get pull requests and you have multiple contributors, because that means people are very interested in your project and they want to work on making it better. And just here's some screenshots of what that would look like on GitHub. So this is an old pull request made by Rich Troughton, and there's conversations related to what it all entails. The second tab over has the number of commits, and any given pull request can have many commits as it's sort of reworked over time. And this is really useful, which it shows you exactly what files have changed. So you don't, when you get a pull request, you don't have to go digging through their project, trying to figure out, okay, what did they break or anything. You can look and see exactly how it differs from your project. I think we can stop for a second. Do you have any questions on collaboration?
Once your change has been merged back into the master or the versionators, do you have to do another fork in order to then update after they've made any changes to pull down again and then
Okay.
submit more of your changes to it?
So I think the question is, so once your pull request is accepted, how do you maintain your original or your fork of that project? And many cases, I think a lot of people just delete it because if they don't have any more pull requests, there's probably no need for it. If you're interested in continuing to create new pull requests, you'd probably keep it open, and I think you would do a pull down changes, and you continually update against that master.
I believe you can. Yes, you can merge changes from them. Great question, yeah. I mean, the deleting is, because I know that some people fork a project and they've got their own set of changes that they don't necessarily want to push back to the original maintainers because it's not applicable for the original project maybe. But some of them may be. So they either delete it, as Matt mentioned, or there are other ways of merging it back. It's been a while, but it is doable because I've seen it done.
If you Google, there's usually like a one-line git command that I usually use to pull down from the original or update my fork.
Yep.
And if you're contributing regularly, you probably want to maybe ask for contributor rights.
Right.
So you could then maybe push to a dev branch.
Yep. Make a lot of good pull requests. They'll like you, then you get in. That's how it works, right?
Right. And be nice.
Yeah. Yeah.
Just wondering quickly, the issues and comments, is that part of the Git repository or is that just a feature of GitHub?
Issues and comments are a feature of GitHub.
Gotcha. Okay. One last question real quick. You mentioned before doing a git bear share. I've done git bear before. What does git bear share do?
Sure, yeah. I can answer that, Matt, if you want to. We're being nice to talk a little louder, too. Okay. The shared, so the question was, what does the git init, bear, and shared do? The shared is for when it resides on a server versus on a local machine. So it would be, the shared would set it up in such a way that multiple users can commit to it. They'll be going to that server as different user IDs. So it allows it to reside on a server, and that's one thing you want to enable for it to work in case people try to commit at the same time. But it's also related to UMask and other default permissions as well. So go to git-scm.com and search documentation for shared or git init, and it'll tell you some more about that there. So yeah, sure, you bet.
So I think as Git has become a larger part of my workflow and sort of our team's workflow, it's kind of made sense to try to use it more for automation. So just a few examples of how that might work would be automatic emails. So if you push a new commit, send a new email to your entire team, letting them know what the changes were. You can also do a lot of push notifications to Slack channels, IRC, Twitter, HipChat, etc. Just focusing on that collaboration aspect, letting your team know what's been changed, and give them a link directly to check that out if they're interested. Other ways you can integrate would be, I think Justin touched on this, would be webhooks. So you're creating hooks based on changes to your repository. So if a branch is merged, if there's a new commit, new issues created, have that trigger different events that maybe interact with other systems. And other methods, so sometimes with continuous integration, which we'll get to shortly, they use different agents and runners. So on commits, after these hooks execute, they can trigger events, maybe testing your code on a dev server, updating your auto package server with the latest commits of your new recipes. And another method too, which I've usually done with GitHub, when you're not actually the project owner, you would do polling, so you're regularly just pulling a certain Git repo for changes. And that all fits into many continuous integration systems. In order to accomplish some of these automation tasks, a lot of times you can just use scripts. Git is very command line friendly, so you can wrap a lot of launchd, cron tasks and scripts around that to automate Git pulls. If you use Autopackager, essentially Autopackage is all wrapped around Git already. So when you're using Autopackager to schedule recipe repo updates, what it's doing is just doing those Git pulls, Autopackage updates on those repos. And so continuous integration, a few examples of that would be something like Jenkins. Atlassian has a product called Bamboo, and also GitLab has sort of the minimalistic continuous integration feature built in. And Travis CI, if you use GitHub heavily for a lot of your internal projects, is a hosted solution that ties into GitHub very well. So webhooks are, we already went over this a little bit, I guess, but event notifications basically that let you interact and easily trigger events to happen across different systems. So those could be commits, push either a tag or a branch. If there's a new release of some project maybe on GitHub, a new auto package version is released. Issues are created, documentation updates, someone created a new fork. They're also useful for a lot of kind of internal, if you're web developers might use them for updating, notifying, building, testing, or deploying. So a lot of those might fit into kind of that, again, that continuous integration workflow to you're generating your code, you're editing your code on your local workstation, you push that up to Git, your continuous integration system then maybe receives a webhook, pulls it down, sends it off to your development web server, and runs some sort of tests that help you evaluate whether or not this was a good commit or not. And then a lot of times, all tied in through Git, you know exactly who made the change, when the change happened, so you know exactly who to blame if it fails. So we've had a few different automation ideas, but one example is you may want to set up part of your website or a whole website using Git and actually update your web server with Git, which would easily then allow you to revert to a previous commit. Also different like config files or monkey repos, anything stored on a web server. Git is very powerful there. So for example, something like we use GitHub, or we use GitLab, and that has what's called a runner. So you would push to GitLab, you have runners installed on different servers, and you set it up so those runners are then triggered and run scripts or other different tasks after it receives a commit. And this fits in with the automated testing, building, prototyping. Anything there?
Yeah, we're about 12 minutes, so that's fine. Well, I was taking a drink really quick. There was a .git folder security thing just to be aware of. So if you can Google it, but basically it's possible that you could push a Git repository to a server, and then that directory, if it's maintained by Git, which it probably would be, there would be a .git folder, and some hackers could see that that directory was there, and there was some type of exploit, short-lived, but it was there. So read up on that, and you can use permissions to restrict that from would-be hackers.
So at Penn State, we use a lot of tools. And at first, when I started this slide, I was going to start drawing arrows and how they all fit together, and then I realized I'd basically probably be connecting everything to everything, so that really didn't help. But we primarily use GitHub for a lot of public projects, and we use GitLab for all our internal projects, or at least either internal to our group or internal to Penn State, so we can collaborate with others in our organization. And we also use AutoPackage very heavily. So AutoPackage gets its recipes obviously from a lot of people like you on GitHub, and anytime those are updated, something like Jenkins can watch those repositories and then trigger updates on, trigger the AutoPackage server to say, this repo's been updated, so maybe you should grab a new copy. We also use that internally, so when we push commits to our internal AutoPackage recipes on GitLab, those automatically get pulled down. So between GitLab has a continuous integration runner, so that's installed on a GitLab or AutoPackage server. So when GitLab is updated, when this repo is updated, this commit says go update those AutoPackage recipe repos. And also, for notification, our whole team is on Slack. So when when someone on the team updates a AutoPackage recipe in GitLab, GitLab has great integration with Slack, so it automatically pushes notifications to the entire team saying, here's what changed, here's their commit message, which is another reason why it's important to write good commit messages, because then that's sent out in Slack so everyone can see it, exactly what changed, and they know if they're interested in checking out that change or not. And there's a link right there so they can jump right into that commit, which will then on GitLab take them directly to the diff so they can see exactly what files have changed. And they can say, whoa, wait a minute, maybe that broke something, so we need to take another look at that. AutoPackage then also, we use a software deployment tool called BigFix. AutoPackage has the ability to then add new content to BigFix. So the recipes are coming from GitLab, GitHub. AutoPackage runs them, creates new BigFix content, adds them to our console. And then one feature we use Jenkins for, which is another continuous integration product, is to then maybe trigger a job to run against a group of test systems. So those new software packages that were added are then tested against a group of test systems. And then that report from Jenkins can get emailed or pushed to Slack saying, okay, well, every morning here, this is the new software that's available. We've already tested against the test systems, and here's what the results are. So if everything looks good, maybe take a closer look at it, and if it looks good, then send it out or deploy it. And if something broke, then we need to figure out what happened. And even then, we've got the Git commits, so we can figure out exactly what happened, and maybe who to blame there too. And then sort of to bring it full circle is we spend a lot of time automating stuff into BigFix, but we also spend a lot of time manually in there creating content, auditing computers, creating new software deployments that just don't work in AutoPackage. And so nightly then Git also allows us to we use Git as a archiving tool as well. So every night we have scripts on Jenkins that dump all the content from BigFix and back into a GitLab repository, and it works really great to see exactly what changed and who changed it. We have hundreds of operators in BigFix changing content every day, and so really all these tools, they have certain tasks that they do really well, and we use them all together, and I think it's worked great for our environment.
Mm-hmm. It's always fun to see the emails from when Matt's processed. Now, there's a lot of hand waving here, we understand. This has been in a while in development. He works in my group, but it's always fun to see the emails from this system. All of these new applications updated. It's just awesome. And he didn't have to do, well, at that time, much, because he's automated it so beautifully. So, thanks, Matt.
Yeah, no problem. So I think some of the lessons we've learned is use the tool that works best. Don't force a tool to try to work just because maybe you're already using it. Don't try to make it do something it's not meant to do. And don't be afraid to adopt new tools if you feel they work better, and experiment. Try to keep it simple, but also keep it robust. Keep your individual components very, very simple, and make them easy to troubleshoot. Try not to create too much black magic, so your future self or your coworkers can't figure it out. Send lots of notifications, but be very categorized and specific about what those notifications are. If your continuous integration system like Jenkins allows you to determine, hey, this thing, I got a new commit and it failed, and it knows that it's a failure, then make sure you send that into Slack as it's a failure and high priority. Like, everyone take a look at this. We've had a lot of positive experiences working with both internal and external collaborators. So we use our Penn State Git resources very heavily. We also use GitHub very heavily. Just use whatever makes sense and share whenever possible. And don't try to use try not to use Git for what it's not meant for, but leverage the powerful features that it has, and it has a whole lot of them.
If you want it, go ahead.
Sure.
Yeah.
And I guess this is maybe more my experience, but so when you're starting to learn these things, don't be afraid to just start small. Start with, like I said, maybe some simple documentation, commits or pull requests, or however you need to start. But I think it has a place for really anyone who wants to use it. And then start just with a Git repository on your local system, and when you're ready, start looking at how you can push that to GitHub, Bitbucket, or if you have to, set up your own SSH hosts. Like I said before, write good commit messages. They're there to help your future self, your coworkers, anyone on the internet who's trying to figure out what you did and maybe contribute to your project or learn from what you did. Helps you to be nice to your future self. And commit messages are very self-documenting, so they make great release notes if you write them very well.
It's not me. Interesting buzz. Okay, it's gone. Everybody's awake.
Like I said, try to keep it simple, but also Git makes it very powerful to go back in time if you ever make any mistakes. So don't be afraid to experiment. Anyone who's ever checked out that Git repo has a full copy of it. So, and once you're ready, automation and integrations with all your current systems are very powerful. And don't be afraid to experiment with those either. There's a lot of good resources out there. These are a few.
Sure. The top one basically is a URL for the cheat sheet. This is not something we created. This goes basically to git-scm.com. If you go into documentation, it just goes to the link that says cheat sheet. It's very handy for the command line usage. And then the other various ones listed below that. So, and yep.
If you haven't already experimented with it, if you go to try.github.com, it's an easy, I think, web-based tutorial that makes it very simple and easy to learn Git. They claim 15 minutes, I think. Atlassian has some good training and resources on Git, obviously, and
another URL for workflows. Basically, this one jumps to Atlassian's workflows listed and all of the various different options. So it's go shopping for the workflow you want to buy. So lots of options to look at there. Oh, and the O'Reilly, McCullough and Berlung on mastering Git is an excellent video tutorial system. It's fantastic. So they really know what they're doing. And I watched that a couple years ago. It's fantastic. So if you can get your hands on that, I highly recommend it. So
thank you, everyone.
Thank you.
I think we can take a few questions.
Sure. There's a lot of information. Are there any questions at all? Sure.
So where I'm coming from, my whole office uses Subversion currently.
Okay.
Obviously, a lot of the open source tools here within the Mac. Oh,
Nice.
this is actually still around. So I was saying I come from an office that uses Subversion, but we're small, and so I feel like we could change to using Git. And a lot of the MacAdmin tools, are all on GitHub and things like that. So I'm probably personally going to start using it. What's a good argument you think I could present to convert the rest of my shop to using Git over Subversion?
Search for Justin Elliott, convert to Git. I actually created a blog. It's a short blog entry, but it's There are many reasons. It's easier for, you don't have to edit properties to do the ignores. You're not stuck to being connected to the network all the time. Branching, or rather merging, actually works. It's easier. I have many more reasons there too. I found it to be a lot quicker. It's a lot faster for doing updates. If there's somebody, because Subversion takes longer to do updates from there. You have the full repo with Git, so you take more disk space, but man, is it fast. So,
Thank you.
Sure, absolutely. Any other questions? Nope. Okay. Yep. Heads up. We are throwing the catch box around. Protect your laptops and drinks. Okay.
I don't
Yeah.
use Git, but I put a lot of my comments and version stuff on my bash scripts. Do you find that you have to do a lot less now on Git? You rely on
Hold on one
pushing a
second.
lot of your comments?
I'm sorry. Can you repeat the question? I'm sorry. Thanks.
You-
We're gonna.
Do you
Okay.
push like a lot of your comments and version information just like into Git and take it out of the script per se, or like, you know, it's just like breaking up your scripts that you may have for
Sure.
automating certain things. It's good etiquette to say, hey, this part of the script is going to do this, but
Right,
you
right.
also have some of that stuff happening on,
Right.
I guess, Git. So how do you decide what makes sense to put where, or the etiquette for that?
Yeah, I understand the question. I can take that, or if Matt's got some.
I think it maybe depends how
Yeah.
complex your project gets. I think there's still need for like inline code comments, obviously, but once you start getting like more advanced usage documentation for how to use your script, you know, how to modify it, do more advanced things with it, then it probably makes more sense to move that out. It's probably much easier to edit, you know, in GitHub, in Markdown versus Bash script. So.
One thing I used to do the exact same thing where I'd put my version in the comments, and one time my comments were longer than the code itself at one time. But where you can put them in the commits. Commits are also nice for release notes. So you could say, do a commit, preface it with RL : for release notes, and then you could look at your commits, grep for them, and then put them in saying, oh, this is what I did for this version, and update your version's file. So when it's fresh in your mind, you do the commit, and you could say, this is for release notes, and then it helps you and others to say, this is what I did. Because you'll have lots of micro commits that people don't need to see, but then they'll want to see the English version. This is fresh in your head. You could have that in a separate file. It comes down to workflow. But I used to do the same thing, and then I switched it to a model where release notes, pull those out, put them in another file, and it's a lot easier to collect them when I'm ready to release.